In this video, we're going to go over section 8.2, which is called surface area and volume. This section is all about three-dimensional figures. The first topic that we need to talk about is volume. Volume is a measure of the amount of space occupied by a three-dimensional object. Volume is always measured in units cubed. Alright, so you'll see something like inches cubed, or feet cubed, or centimeters cubed, yards cubed. It's always units cubed. Volume was originally investigated in the course of bartering and commerce, so whenever people were trading grain, wine, oil, or other goods, various vessels or containers were used as standards, but different cultures used different standard vessels, so they developed elaborate conversion systems to determine equal measurements for goods. So you may have seen these on your conversion sheet, some of these weird units of measure that we don't use anymore. So like hogs, heads, cords, pecks, and bushels. So these are the modern day legacy of early vessel measurement. If we're dealing with a figure that has identical cross sections, then this is the formula that we will use. I'm going to talk more about what it means to have identical cross sections in a minute, but first I want to read the definition. If a three-dimensional figure has height h and identical cross sections from top to bottom, each of area A, the volume V of the figure is volume equals area times height. So here are some examples of figures that have identical cross sections. First we have a cylinder. So this has an identical cross section because you could cut it at any point through here and you're going to get the same shape. So you can imagine this is maybe like a can of corn or something, and then you cut a slice out of it. It's going to have the same shape cross section no matter where you cut it. A second example would be a rectangular box. So you can imagine this is like a maybe like a box that your Christmas tree came in. Anywhere that you cut it through the center, it's going to have identical shaped cross sections. One way that I like to help explain what having an identical cross section means is to give an example of something that does not have an identical cross section. So here we have a cone. You can imagine this is like the shape of the little cup that you get at those little Culligan water fountains. So this is an example of a shape that does not have an identical cross section. So what that means is that if you cut it here, if you cut it along these lines, so let's say that you make a cut here, these are going to have different shaped cross sections. Right, so they're going to have different widths depending on how far down you are on the cone. So this is an example of something that does not have an identical cross section. Now we can still find the volume of that figure. We just have to use a different method, which we'll talk about later. So here we have a couple of objects, or a couple of containers. It says, referring to the cylindrical and rectangular water containers below, determine which holds more water. So on the left we have a cylinder that's 16 inches tall by 14 inches wide, and then on the right we have a rectangular box that is 12 inches by 12 inches by 17 inches. We're going to start by finding the volume of the cylindrical container. I'm finding the volume because I want to determine which one of these containers will hold more water, and whichever one has the higher volume will be the container that will hold more water. So to find the volume, since this is a shape that has an identical cross section, we're going to use the formula from the previous page, so volume equals area times height. Now the area part is pretty simple. You're just going to look at the bottom of the shape, and that's going to tell you which of your area formulas to use from section 8.1. The bottom of this shape is a circle, so we're going to use the area formula for a circle. The area of a circle is pi r squared, so pi times the radius squared. So that's volume equals pi times r squared times the height. This example tells us that the diameter of the circle at the bottom is 14 inches. Remember, the radius is half of the diameter. So what should the radius be? The radius, let me try that again. The radius will be 7 inches. The height of this cylindrical container is 16 inches. So now we just need to plug in our numbers. So volume equals pi times radius squared, so 7 squared, times the height, which is 16. You multiply that out in your calculator, that gives you volume equals 2,463.01 inches cubed. Alright, so we'll come back to that in just a minute, but for now we need to find out what the volume is of our rectangular container. Now let's look at our rectangular container. Since this figure also has identical cross sections, you're going to use the volume formula from a couple pages back. So volume equals area times height. Now, to figure out which area formula we're going to use, we're going to look at the bottom of the shape. So here you can see the bottom of this shape is 12 inches by 12 inches. So since the sides are identical, that means the shape is a square. We know the area of a square is base squared, so b squared. So we have volume equals base squared times the height. Our base here is 12 inches. So we have volume equals 12 squared times the height. The height of this rectangular box is 17 inches. So let's plug in 17 for the height. So we have volume equals 12 squared times 17. So if you multiply that out, the volume equals, the volume of the rectangular box or container is 2,448 inches cubed. Remember, I told you that volume is always in units cubed. Now let's see which one had the greater volume. The cylindrical container had a volume of 2,463.01. The rectangular water container had a volume of 2,448. Which one of these is the bigger volume? The cylindrical water container has the larger volume, or the greater volume, so that is the container that will hold more water. The next topic we need to talk about with three-dimensional objects is surface area. The surface area of a three-dimensional figure is the sum total of all of the areas of all of the surfaces that compose the figure. Although a formula for the surface area of a rectangular box could be given, it's not necessary because we already know how to find the area of each one of the little rectangular faces of the box. However, if we're dealing with non-rectangular objects like cylinders and spheres, they have specific formulas that we can use to find the surface area. I'll show you both of those formulas before this video ends. And one last note, the surface area, just like the area from section 8.1, is measured in square units. Here's the formula for the surface area of a cylinder. So the formula for the surface area of a cylinder, one of my students explained it this way, and I think this is a good explanation. What this means is, like, if you were covering the entire cylinder with wallpaper, this is how much wallpaper you would need. So that's what the surface area is going to tell you. So it's going to tell you how much of the area is on the entire outside of that shape. So the formula for the surface area of a cylinder is A equals 2 pi RH, so 2 pi times the radius times the height, plus 2 pi r squared. Right, so r is the radius, h is the height. So here are the same two shapes from example 1, and it says, referring to the cylindrical and rectangular water containers below, determine which has the greater surface area. Alright, so we already know that the cylinder had the greater volume, so let's see which one has the greater surface area. We're going to start with the cylinder. Now this is the one that has the special formula, so I've pulled up the formula there. So we have area equals 2 pi RH plus 2 pi r squared. The diameter of the circle at the bottom of this shape is 14 inches. We know that the radius is half of the diameter. We just did this, so you already know that the radius is 7. And we know that the height of our cylindrical water container is 16 inches. So let's plug in 7 for R and 16 for H. That gives us surface area equals 2 times pi times 7 times 16 plus 2 times pi times 7 squared. If you plug all of this in your calculator, that gives you surface area equals 1011.59 inches squared. Now your book uses A to represent the area, and it also uses A to represent the surface area. If it helps you out to distinguish these, you could always call this like SA for surface area, if that helps you. Sorry, that was a really bad S. So you could use SA for surface area instead of just A. That helps you distinguish those. Alright, so now we know the surface area of the cylindrical water container. Now we need to figure out the surface area of the rectangular container, and then we'll figure out which one is greater. If you're dealing with a rectangular container or a box, you don't need a formula to find the surface area. All you need to do is figure out the area of each one of the sides of the shape and then add all of those together. The top and the bottom here have the same area. So you can imagine a box, like an Amazon box. The top and the bottom are going to have the same size. So we're going to split this up into two parts. We're going to find the area of the top and the bottom. Then we're going to find the area of the sides. Then we're going to add those together. So if you're looking at the top and the bottom shapes, we know that those are, actually they're squares, but I use the rectangle formula here, which is fine. So we have area equals base times height. The base here is 12 and the height is 12. It's a square. So area equals 144 inches squared. Now I could have also used the formula for the area of a square, which is base squared, which would have been 12 squared, which is also 144. Now I need to find the area of the sides. So here's the side. You can see that the base is 12, and if you look over here on the side here, the height is 17 inches. So we have area equals 12 times 17. 12 times 17 is 204. So the area of the side is 204 inches squared. Now to find the total area, the total surface area, you're going to have to add together the area of the top and the bottom plus the area of the sides. Now notice what I've done here. I've taken the area of the top and the bottom and I've multiplied it by 2. I'm multiplying by 2 because there are two of those exact shape. There's a top and a bottom. For the sides, I'm multiplying by 4 because there are exactly 4 sides that have that same shape. So if you multiply this out, we have surface area equals 144 inches squared times 2 plus 204 inches squared times 4, which gives you surface area equals 1,104 inches squared. Now, like I said, if it helps you distinguish these, you could call this surface area instead of just area or just A. Now let's figure out which one of these containers had the greater surface area. The cylinder had a surface area of 1,011.59. The rectangular container had a surface area of 1,104 inches squared. So in this case, the rectangular container has the greater surface area. So if you're thinking about what this means in your mind, you could imagine that it would take more wallpaper to cover the outside of the box than it would the cylinder. Now we talked about another one of the non-rectangular shapes that have special formulas was a sphere. A sphere is a three-dimensional counterpart of a circle. It's the set of all points in space equidistant from a fixed point. So it's just a three-dimensional circle like a ball. The fixed point is called the center of the sphere. The line segment connecting the center and any point on the sphere is the radius. Right, so if you go from the center to any point on the sphere, that's called the radius. The line segment connecting any 2 points of the sphere and passing through the center is the diameter. And we already know that the length of the diameter is twice that of the radius. Another way of saying this is that the radius is half of the diameter. Here are the two formulas for the volume and the surface area of a sphere. The volume V of a sphere of radius r is volume equals 4/3 times pi times r cubed, or radius cubed. The surface area of a sphere of radius r is 4 pi r squared. Here we have a problem from your homework. This is section 8.2 homework problem number 2. It says find the volume and the surface area of the figure. Round your answer to 2 decimal places. It tells you that the diameter of this sphere is 7 5/8 inches. We know that the formula for the volume of a sphere is 4/3 times pi times r cubed. So we know the diameter, but we need to know the radius. So in order for us to find the radius, let's convert 7 5/8 into an improper fraction so that we can figure out what the radius is. Here are the steps for converting a mixed number into an improper fraction. The first step is to multiply the whole number by the denominator. Then add the answer from step 1 to your numerator. The last step is to write the answer from step 2 over your old denominator. So here's our mixed number. We're going to convert it into an improper fraction. We start by multiplying the whole number by the denominator. So we're multiplying 7 times 8. 7 times 8, or 8 times 7, is 56. You take that number and you add it to the numerator. 56 plus 5 is 61. You take this number, 61, and you're going to write it over your denominator. That's going to become your improper fraction. So 7 5/8 is the same as 61 over 8. This is our radius, so let's plug that back in. Excuse me, I said that was our radius, but that's actually our diameter. So the diameter, we just converted it into an improper fraction. The diameter is 61 over 8. In order for us to find the radius, we just need to figure out what half of that is. So the radius is going to be 61 over 8 divided by 2. Now I've tested this on my calculator, and on my calculator it seems like you don't need parentheses around the top, but if you wanted to play extra safe, you could just go ahead and throw a set of parentheses around the top before you divide it by 2. So 61 over 8 divided by 2 is 3.8125. And make sure you include all of those decimal places so that we don't have any rounding mistakes. Now that we know our radius, we can plug that into our volume formula. So the volume of the sphere is 4/8 times pi times r cubed. So plugging in 3.8125 for the radius, we have volume equals 4/3 times pi times 3.8125 cubed. If you plug this into your calculator, that's going to give you volume equals 232.12 inches cubed. Now notice in your homework, it's already got the inches cubed in there for you, so you don't need to type that in. You will need to be able to recognize the correct units for the final exam though. Now let's find the surface area. The formula for the surface area is 4 pi r squared. We already know that the radius is 3.8125. We found that on the last part. So let's plug in that radius. So we get surface area equals 4 times pi times 3.8125 squared. So the surface area equals 182.65 inches squared. The next three-dimensional figure that we need to talk about are cones. Two other three-dimensional objects are the cone and the pyramid. The only difference between a cone and a pyramid is that a cone has a circular base and the base of a pyramid is a polygon. It's usually a rectangle or a square. In either case, cross sections parallel to the base all have the same shape as the base, but they differ in size. So starting at the base, the cross sections will get progressively smaller until they reach a single point at the very top of the cone or the pyramid. For both a cone and a pyramid, the volume is 1/3 the product of the area and the base times the height. The area of the base times the height, excuse me. So here's that formula. Volume of a cone or a pyramid. If a volume or a pyramid has, if a cone or a pyramid has height h, and if the area of the base is A, the volume V of the figure is V equals 1/3 times the area times the height. These two, you're going to have two shapes that look exactly like this on your homework. So hopefully this will get you good and prepared for those problems on the homework. Example 3 says, find the volumes of the cone and the pyramid shown below. Let's start by finding the volume of a cone. We already know that the formula for the volume of a cone or a pyramid is 1/3 times the area times the height. Now to figure out which area formula that we need to use, once again we're going to look at the bottom of the shape. The bottom of the shape is a circle, so we're going to use the area formula for a circle. The area of a circle is pi r squared. So we need to find the radius and we need to know the height. Notice that the height is involved right there. Alright, so since the diameter of the circle is 8 feet, we know the radius is half of the diameter, so the radius is 4. The height of this cone is 6 feet. So let's plug in 4 for the radius and 6 for the height. So here we have all spelled out here. Our formula for the volume of the cone is going to be 1/3 times pi r squared times h. So plugging in 4 for r and 6 for h, you get 1/3 times pi times 4 squared times 6. Multiplying this out, you get volume equals 100.53 feet cubed. Once again, remember, volume is always in units cubed. Now let's find the volume of the pyramid. We already know the formula for the volume of a cone or pyramid is 1/3 times the area times the height. Now this time, the bottom of the pyramid is a square, so we can use the area formula for a square. The area of a square is base squared or b squared. The base of our pyramid is 8 feet, and the height of our pyramid is 6 feet. So we have volume equals 1/3 times base squared times height, so we can plug in 8 for the base and 6 for the height. So that gives us 1/3 times 8 squared times 6. If you multiply that out, that gives you volume equals 128 feet cubed. That's everything for this section. If you have any questions, make sure that you either email me, use the Ask My Instructor button on your WebAssign questions, or you can post in the Q&A coffee shop discussion board on D2L.